Hello and welcome to this practice paper walkthrough for paper 2, OCR Computer Science J277. And the idea behind this is that you work your way through the questions, get a chance to see what kind of questions you will get on the exam and what your exam paper will look like, and also have an opportunity to try and practice these questions yourself, and then you can self-mark your answers and see what grade you would have got on the test. Okay, so here we go. So this exam paper is for paper 2. It's computational thinking, algorithms and programming. You get 1.5 hours on the test, and this is the key information that you will see on the front cover. As mentioned in the other video, at one point in my career, I remember a student having pages missing from their exam paper. So I recommend just making sure that you have all the pages in your actual paper. This particular one has 20 pages, which makes it sound like a lot, but you are given a lot more space to answer certain questions. Okay, as it says here, the total mark for this paper is 80, and we're going to work our way through the questions now. Make sure that you write in black ink. Obviously, you're going to need to know your centre number and candidate number when you do your real test. So question 1. It says here, complete the truth table in figure 1 for the Boolean statement P equals not A and B. So the key to this question here is to really think about what you're going to do for these two gaps in the question. You need to say what the output is going to be, which is P, for this logical statement. Now, as I have mentioned in some of my videos online, you might want to add an extra column in here for A and B, and that way you can then reverse the column that you've put in for A and B to get your output, because P is the reverse of A and B. So sometimes it helps to add in an extra column, and therefore it will be easier for you to work this out. Obviously, you only need to put ones and zeros in, whichever you think are correct, and then we can move on to the next question. Okay, part B. This one has given us some logic circuits, some logic diagrams, and it wants you to identify which is the correct logic diagram for P equals not A and B. So the best thing for you to do is take your time, examine these logic gates, think about which logic gate is for which particular Boolean operator, and then from that point you should be able to easily identify which one is the correct diagram. All you have to do is tick one box, and that is that question completed. Then we're going to check on the mark scheme, and you'll be able to see whether you got those questions correct or not. Okay, so here is the mark scheme for 1A and 1B. You can see that there is only one correct answer for both. You need to have 1, 1 as the only possible answer for the first one. It does say that you can put true or T for basically saying that the Boolean answer is true. And also for 1B, there is only one correct answer. You have to tick that particular logic circuit. It should have been fairly easy. If you know what the logic gates are for the different operators, then you will know that that was the only one with an and a not. Okay, let's move on to the next question. Here's question 2. A program needs to perform the following tasks. Input two numbers from the user, compare both numbers and output the largest number. Complete the pseudocode for this program. So in this particular case, my first tip to you would be ignore the length of the dotted lines. Some of the dotted lines are way longer than they need to be. So but they've obviously done that for a reason, to not try and give away the answer. So try to ignore the dotted lines and focus on what you think the answer would be. So for num1, we are asking it to get an input from the user. So you just need to complete that actual code. Once it gets down to the third line, there are 2 gaps that you need to fill in. As I say, ignore the length of the dotted lines and just focus on what you think the answer should be. And once you've had a little go, we can move on to the next question. I think it's really important that you sort of like think about what the program's doing and almost ignore what's already there and just focus on what you would do for that particular program. So go back to the original tips, which are think about what variables you will need. In this case, they're already provided for you. Think about which ones are inputs. In this case, it's already telling you. What processing needs to take place. In this case, we are doing some sort of comparison. And it says output the largest number. So you need to think about what the output is going to be for this particular program. It's actually fairly easy when you take your time. So have a little go and then we can move on once you are finished. You're going to need to pause the video now if you're going to attempt the question. Okay, so this is the second part of the question. It says a second program needs to perform the following tasks. Input a number from the user, double the number input and print the result, and repeat bullets 1 and 2 until the user enters a number less than 0. It does say that you need to write an algorithm for this program. Now, from my experience, the students that I've taught tend to panic when they see that they have to write a full algorithm. Sometimes even like the anxiety takes over and they just kind of leave out the whole thing. Just because you don't know how to do one part of it does not mean that you don't know how to do some of the algorithm. At the very least, you should be able to get some inputs from the user. If you're really struggling, you can even look back at the question before and it tells us how to get an input from the user. So you could start by looking at that. Think about how you're going to get your inputs. Think about what you would call your variables. Then think about what processing needs to take place. In this particular case, it says double the number. And then think about what your output is, which in this case says print the result. The third bullet point is the bit where some people might struggle. It says repeat. So when there is a repeat, you know that there's going to be some sort of iteration and you need to decide what type of loop that you're going to put all of your code into. Okay, if you are using a certain type of loop, you need to think, does it tell me how many times I want to repeat? Or is it based on a condition? And if it's based on a condition, what is that condition? By taking your time on these bullets and at least attempting the question, even if you only get the first 2 bullet points correct, you're still going to pick up 2 or 3 marks. Okay, right, have an attempt now. You're going to want to pause the video because I'm going to go through the marks in a second. Okay, here is the mark scheme for this question. For 2A, you have to put in the actual things that are in here because the program wouldn't work if you put anything else in. So for the first one, for A, we need to say input, enter first number. And that should have been the easiest mark on the exam paper really, since directly underneath it's got the exact same thing written. Underneath that, if you know how to do any sort of selection, any sort of decision, you would know that it starts with if. Then because we are comparing 2 values, the 2 variable names, the only possible option would be num2. And then at the end, we need to output, so we have to put the word print in, and obviously we need to print the correct one. So because we're comparing and the greater than symbol is facing the way that it is, we need to print out num1 and then num2. You can't put anything else to get any other marks. For 2B, there are a number of ways in which you could have done this. I think everybody that has actually really tried and listened and been in all their lessons over the last 1.5 years or so, you should know how to take an input. And at the very least, you could have looked at the question before to see how to actually do it. So the first thing we do is ask for the number as an input. We double the number and we output it. My example in the bottom right is something that I've seen done quite a few times. Some people don't like to use a while true loop because it's essentially a forever loop. However, doesn't mean it doesn't work. So this forever loop is saying while true, so in other words forever, we're going to ask the user to input a number. If the number is less than 0, then we're going to break the loop, and if it isn't, we continue. If we continue, we double the number and store it in result, and then we print results out, and it will go back to the start of the loop and ask you to input another number, and so on and so on and so on. For the exam board's mark scheme, it's used a while loop, but while number is greater than or equal to 0, and done it that way around instead. It's essentially the same lines of code, just a slightly different way of doing it. So you would, as it says on here, you've got 5 bullet points. If you've got some sort of loop that is created properly, then you will get a mark. If you've checked the condition, saying whether it's less than or greater than, then you get another mark. If you've done your input, if you've got your multiplication, and if you've got your output, then you will get 3 marks still. So even if you didn't know how to do the loop at all, you can still get 3 marks. Okay, let's move on to question 3. It says the database table results stores the results for each student in each of their chosen subjects, and it gives us a little preview of what the table actually looks like. It says complete the SQL query to return all of the fields for the students who take art. Now, these SQL questions are really important that you read the question carefully. We're looking for some key information. Number 1 is what the table is called. Number 2 is what the columns are called. And number 3 is usually what they're asking you to return. In this case, it says all of the fields for the students who take art. Now, this particular question's being quite kind in that it tells you the actual SQL commands, select, from, and where. You just need to fill in the details. So try to remember what you've learned for SQL. Think about what a typical statement looks like and see if you can attempt the question. We'll go through the mark scheme soon and you'll be able to see whether you got it correct. Here's the mark scheme for that question. Interestingly, all the way through the whole course, it talks about using the wildcard star for select all. So in the question, when it said select all fields, I would have personally put select star. It is allowed and you do get the mark for it, but in the suggested response, it says select student name, subject, grade. Now that is all the fields, so select star, I think, would be more efficient. Then underneath it says from results, that's the name of the table which was in the question. And then where subject equals art, that is what the field that it tells you to actually look for. It wants you to get that particular subject. So that's the only thing that you're allowed to put in. You're allowed to put exactly as it looks on the 3 bullet points, or you can put select star and then the other 2 bullets should look the same. If any of those are not correct, then you don't get any marks. In other words, if you've put something slightly wrong, like from table or from students or from subject or something, you don't get the mark for that bullet point. Okay, for question 4, it says a program creates usernames for a school. The first design of the program is shown in flowchart in figure 2. And here we've got the actual flowchart with all the flowchart symbols. At the bottom it says, for example, using the process in figure 2, Tom Ward's username would be Tom Wa. So it's kind of giving you an example of what would happen when you put the data through the flowchart. So starting from the beginning, it says input first name and then input surname. Our 2 inputs in this case are Tom Ward. And then underneath, it's created a name and it uses first 3 letters of first name. And then username equals name plus first 2 letters of surname. And at the end, it outputs that username. And it's told us that that would be Tom W.A. Here, it says state using the process in figure 2, the username for Rebecca Ellis. So carefully trace your way through the algorithm, put Rebecca Ellis in, and then write down what would get output at the end. Have a little go, and we're going to move on. Now this question needs a little bit of time to read over. It says the program design is updated. So straight away we know that we need to look at that original flowchart and think, what have they actually changed? It says that if the person is a teacher, their username is the last 3 letters of their surname and then the first 2 letters of their first name. If the person is a student, their username is the first 3 letters of their first name and then the first 2 letters of the surname. What would the username for a teacher called Fred Biscuit using the updated process? So going back to the algorithm and putting your information through, if you type in Fred Biscuit, it's going to follow the first bullet point of this question. So what would their username be? Take your time, read it carefully again, put your answer in, and we can move on. So here's the mark scheme for the question so far. The only possible answers you can have are Reb, L, and Uit, Fruit. And they're the only 2 things that you can have. There was no other interpretation. So mark your question and we can carry on with the test. Now this says write an algorithm for the updated program design shown in question 4B1. So I've put the picture of what that was so you don't have to refer back to it. It is the updated algorithm. So what you've got to think about is you've already seen the full flowchart for what it would look like. However, this time there is a decision to be made and it's saying if they're a teacher or if they're a student. So you're going to need to think about how you're going to find that out from the user, whether they're a teacher or a student. And then dependent on their input, it's going to do 2 different things. This is worth 6 marks, so it's really worth the time to take to think about what you actually want to do. So what is it that you want to get as inputs from the user? Once you've got that information, what decision do you need to make? And then what is going to get what's going to get processed and what's going to get output at the end. So it's important that you take your time on this. Think about what you're actually going to write it in. If you want to, you can do it as a flowchart for this particular question because it doesn't say otherwise. It doesn't say you have to use pseudocode or OCR language or a program language you've studied. It doesn't specify. So you could use a similar flowchart to what you've already done. However, you're going to need to adapt that flowchart. Or you could just write it in Python, which is what you've probably been learning how to do for the last year or so. Why not just try whatever you feel most comfortable with? So take your time. You're going to want to pause the video because we're going to go through the mark scheme in a second. Okay, so here's the mark scheme for that question. There is a few different ways you can do this. So obviously the original mark scheme has got bullet points where it says taking first name, surname and teacher or student as an input. So that would be, if you follow that same process that we always do, think about what inputs you need from the user, you should have got that bullet point. Then we need to check if the role is a teacher or student. So using an if statement to check one of the inputs. And then if you've done the actual generation of the username, which should be fairly easy because you've just done it or you've just seen it before. And then output at the end. Now, I've done this in 2 different ways here to make it a bit easier for you to mark. In the bottom left, you can see the code that if you did it in Python, it would look something like that. Now, you don't have to get the exact syntax. You don't have to put last name :-3. You could literally just put last name, last 3 letters, or last 3, basically like they've done in their example before. Or you can do it in the flowchart version, which I've put in the bottom right. And that is just where you use the symbols to show what would actually be happening. The rhombus, the yellow rhombus, is the decision. So if user type equals teacher, we continue down. If it's not equal to teacher, then we go to the right. And that is the 2 different options that you could have used. So take your time to mark what you've actually written. Hopefully you've had a go and at least attempted the question, and you should at least get a mark or 2 for doing the basic stuff near the beginning. Okay, let's move on. So question 5 says a computer game is written in a high-level programming language. State why the computer needs to translate the code before it is executed. So why does a computer need to translate high-level language before it is executed? Think about your answer. You just need to kind of write a very brief statement, no real explanation. Take your time and have a go. For part B, it says either a compiler or an interpreter can translate the code. Describe two differences between how a compiler and an interpreter would translate the code. So you need to really think about everything you know about a compiler and an interpreter and what is the difference between those two things. It is quite a difficult question unless you've revised it or unless you've visited it quite recently. They are very specific differences that you need to put down. So have a little go, write down what you think, and we can check the answers. Okay, here is the mark scheme for that question. So for 5A, you can have any of these. So you could have convert it to binary or machine code, or that this processor can only understand machine code or binary. So essentially, you just have to say something about that's all the computer can understand. So for part B, because it's a comparison question, we need to kind of make statements about different properties of each. So a compiler translates all the code in one go, whereas an interpreter translates line by line. Compiler creates an executable file at the end, where an interpreter does not. Or a compiler reports errors at the end, where an interpreter stops when it finds an error. So that is how you do the comparison. You write one statement for one and then compare it with the other. It says on the right, 1 mark to be awarded for the correct identification and 1 for a description. No more than 2 marks for answers relating only to interpreters and no more than 2 for only to compilers. So if you've just talked about one particular thing and not compared, then you can only get 2 out of 4. Okay, let's move on to the next question. You should be marking as you go through, and that question was out of 5. Okay, question 6. A program uses a file to store a list of words that can be used in a game. A sample of this data is shown in figure 3. And we can see here that it's got crime, bait, fright, victory, nibble and loose. And these words are obviously not in order, so they need to be sorted into order. It says show the stages of a bubble sort when applied to data shown in figure 3. So you need to think about your sorting algorithms. There are 3 sorting algorithms that you need to know: bubble, insertion and merge. And think about what actually happens during a bubble sort. A lot of people struggle to write down the steps, but because you've only got 6 actual items of data, you shouldn't find it too difficult to do this particular question. If you are unsure of how to do this or how to write it onto the exam, go and watch the video on my channel about sorting algorithms and I will explain how to do it on there. So have a little go, attempt the question, and we'll check the mark scheme in a moment. For the second part, it says a second sample of data is shown in figure 4. Show the stages of a binary search to find the word zebra using the data shown in figure 4. Now this data is obviously in order, and we were expected to show the stages of a binary search. This one is much easier to actually write down the steps, or the stages as it calls it here. You just need to think about the binary search method and what actually happens. You should be able to write down in bullet points what the steps are or the stages to find that actual word. So have a little go. You're going to want to pause the video because we're about to go through the mark scheme for the last 2 questions. So the method that they've used on the mark scheme is to kind of show where it would look after each bubble sort swap has taken place. So you need to make it really clear where you are swapping data. Sometimes you're going to need to make more than one pass with bubble sort. So I usually get my students to write down that they've completed a pass, like end of first pass, and that helps to show that you're clear on how a bubble sort actually works. It's also a good idea to kind of label when you've made a swap, or write at the end of the line to say swap or no swaps if there's been no swaps that have taken place. So it's really good if you can actually write it out step by step as you go through, even if it's a lot more writing, because it clearly shows that you understand how to do it. So check what you've got, give yourself a mark out of 4, and then let's look at 6b. So for 6b, it says comparing zebra to orange. So what I do when I'm teaching it is I tell the students to write down what the midpoint is. So the first step is to find the midpoint. So essentially, once you've found the midpoint, you are comparing the value you're looking for to that midpoint. If it's greater than it, you split the data and just keep the right hand side. If it's less than, you would take the left side and get rid of the right. So you're getting a mark for each bullet point, essentially. One for saying find the midpoint, one for saying remove the irrelevant data, and then the other bullet points are for the repeat actions. So in other words, once you've done that, if you haven't found the word, then you need to do the same steps again. At the bottom, you can see how someone's written it out. Compare zebra to orange. It's greater split right compared to wind, greater split right compared to zebra. So that's one way of doing it. Or you can write out the data in multiple steps after you've done your removals. Okay, so mark your questions. I think if you do know how to do the different sorts and searches, it's a pretty easy way of picking up marks. Okay, let's move on. Question 7. The area of a circle is calculated using the formula pi r squared, where pi is equal to 3.142 and r is the radius. A program is written to allow a user to enter the radius of a circle as a whole number between 1 and 30, and then calculate and output the area of the circle. Explain, using examples from the program, 2 ways to improve the maintainability of the program. Okay. So if you know what maintainability is and why it's needed, then this should be fairly easy. We can also pick out specific areas or examples from this program to do so. There are a variety of different options that you could do. There are some where you don't even need to necessarily specifically talk about this program, but in this one it says using examples, so we have to refer to some of the lines of code. So have a little go at the question, think about what maintainability is, how can we make this better in some way, and how can we make it easier for programmers. So let's go. The second part of the question says identify 2 variables used in the program. If you can't do this at this stage, then you really need to increase your revision, because you should be way into this by now. So 2 variables used in this program. I'll give you a clue. There are only 2 used in this particular program, so it should be fairly easy to do. Okay, once you've finished, we can move on. For part C, it says identify 1 item in the program that could have been written as a constant. So you need to know what the difference between a variable and a constant is, and think about what in this program never changes. What is a constant? What could you identify that could have been written as a constant? Have a little go, and then we can do C2, which is give 1 reason why you've identified that item as a constant. So in other words, find what you would recommend as a constant and then why. Okay, the next part of question 7 says tick 1 box in each row to identify whether each programming construct has or has not been used in the program. So it's looking for sequence, selection and iteration. You need to specify whether these have been used or have not been used. So you have to tick 3 boxes. have a little go. Should be a fairly straightforward question, and we can move on. So the final question for question 7 says, identify 2 features of an IDE that might be used when writing the program. So think about what an IDE is, what the features are, and just say any 2 features that you could have used. Right, let's pause the video, make sure you've answered all of those questions, and we're going to check the mark scheme in a moment. Okay, so maintainability is trying to make the program easier for people to understand what's going on, or for somebody else to pick up the code and continue with it. So the examples that you can put in are to add comments. For example, put a comment in to say what's actually happening in the program. You could also put indentation, for example, indenting the if statement. And you could also put using constants. They've already used sensible variable names, so you couldn't really put that one in because they already have. However, I suppose you could, if you haven't actually written the word constant, you could say use a sensible variable name such as pi for the 3.142. For part B, you have to put radius and area because they're the only 2 variables in that program. Part C, you could say 3.142 to make that into a constant, but you could also make reference to the 2, the 1 and the 30 because the 2, the 1 and the 30 also never actually change. For 7C2, the number does not need to be changed while the program is running, and the number can be updated once it updates without. So in other words, any of those numbers that you chose, they never change. If you just say that it never changes during the program, then that is an acceptable answer. For D, selection has been used and sequence has been used, but there is no repetition, there's no loops used in the program. So you should have tick for has been used, tick for has been used, and tick for has not been used. Finally, you can have any of these features. So you can have error diagnostics, for example, finding errors in the code, a runtime environment, editing techniques such as autocorrect or auto-indent, a translator, breakpoint, stepping, and version control. Any of those are okay. However, if you've put autocorrect and auto-indent, they are both forms of editor. So they're both features that come with the editor. So you can't have that. Okay, let's move on. Question 8 says, a teacher researches the length of time students play in computer games each day. Tick one box to identify the data type you would choose to store the data and explain why this is a suitable data type. So we've got 4 data types here listed. The only one missing is character, and you need to decide which one would be best to store the length of time students spend playing computer games each day. So you tick one box, and underneath you need to provide an explanation as to why you've chosen that data type. So take your time, have a little think about it, write your answer, and we can move on. For question 8b, it says the program should only allow values from 0 to 300 inclusive as valid inputs. That means we need to include 0 and 300 in those. If the data entered breaks this validation rule, an error message is displayed. Complete the following program to output invalid input if the data does not meet the validation rule. It says you must use either an OCR exam reference language or a high-level programming language you've studied. So in other words, to do it in Python is absolutely fine. It's already given you part of the program, so it's already got your input, mins equals input, and it says if mins is less than 0, then there's a gap. And again, my recommendation is that don't worry too much about how many dots are there. It's just if they give it a smaller space, then it kind of gives away what you are going to put in, or gives it a longer space, it might kind of promote your answer. So think about what these gaps are going to be. What would the program look like if you did it yourself? It says in the question in bold, there's certain important things that you need to do. Have a little go, think what your 3 gaps are, and attempt your question when you're ready. Okay, so this was the code from before, and it says complete the following test plan for that program. So it's giving you some test data, and it tells you what the test type is and what the expected result would be. So what, in this particular question, it wants to know what you would class as invalid data, and also what the expected result would be if you typed in 300. So it should be fairly easy to think about what the invalid data would be if you read the question from before really carefully. And also, if you read the question carefully before, you will know what the expected result is from the boundary data as well. The expected result should be quite clear as to what is going to be output. It's only going to be either accepted or invalid, so you need to decide which that would be. Have a little go, pause the video because we're going to check the mark scheme now. So for the first part of question A, you could either have integer or real. Doesn't matter which, as long as you give a justification. So you could say integer and say, you know, it just needs to be the nearest hour, or you could say real and say that time has got minutes and seconds, or it might have 1.5 hours or something like that. Any sort of explanation for choosing integer or real. For 8b, because it says in the program that it's got to be greater than 300, you need to put that in, or you can include not. You can include greater than or equal to 301, because it needs to be inclusive of 300. So the first gap is or, because we are checking one or the other. The second one is greater than 300, or you can have greater than or equal to 301. And the last one is print. For 8b part 2, the first one is any sort of invalid test data, in other words anything greater than 300 and or less than 0 you could have as well. And the last one is that the value should be accepted because it was inclusive of 300. The next part of the question says the data for 1 week, Monday to Friday, is stored in a 2D array with the identifier mins played. The following table shows part of this array containing 4 students. And then it shows you a little table with the array in. The teacher wants to output the number of minutes Dan played computer games on Wednesday. The following code is written. So it's got print mins played, that's the name of the array, 3, 2. So it goes along to Dan, which is 3, and down to 2, which goes down to Wednesday. So that's pretty easy, pretty common to understand how you'd actually access one. Underneath it says write a line of code to output the number of minutes that Stuart played on a Friday. So you just need to use the example, write almost identical code, but just change it to Stuart and a Friday instead. So have a little go and we will move on when you're ready. Final part of this question says the teacher writes a program to add up and print out the total number of minutes student 2 played computer games over 5 days. It says total equals 0, so we've started the counter off at the beginning, and then total equals total plus mins played 2, 0, and it goes through all of them, and then print total at the end. It says refine the program to be more efficient, write the refined version of the algorithm. So this is a real challenging question that's been put in to kind of target the higher grade students. you would need to think about how you could reduce the number of lines of code that have been used in this particular thing. So think about what techniques there are for repetition. Think about how you might put that together and just try your best to access this particular code. Think about what you might have to do, what type of loop you might need, and then have a little go. You're going to want to pause the video, make sure you've written all your answers down because we're going to check the mark scheme. Okay, so the mark scheme for 8C just says print mins played 0, 4. So that should have been fairly easy to do when looking at the example. The next one, there's a variety of different options you can do really, but in theory you should just be using a for loop. I actually prefer the second example where it says for x in range 0 to 4 because that's the easiest way of doing it, and when it's something that is very similar to Python. So you've still got to check your total, you've still got to say, you know, what our total is going to be, you've got to have a counter, but then we can do a for loop, and the for loop is going to basically go through and repeat all of the different days. So you could actually have for x in range 5 if you want, because there's 5 days. Then you're going to say total equals total plus and then hours played 2, and you put the x in. So every time the for loop repeats, it will increase x by 1 and by 1 and by 1 and by 1 until it does it 5 times. And then at the end, you're going to want to print out the total. So have a little look at the 2 examples of code, think about what you've done, and you could also check the bullet points. So have you set total as 0 at the beginning, and have you printed out total at the end? Have you used some sort of loop, whether it's a for loop or a while loop? And have you put something about it repeating 5 times? So it's a tricky one really. You'd have to really know what you're doing with code, but if you'd have put some sort of loop in that repeats 5 times, and if you'd have put something about adding up the total and something about printing out the total, then you would have got some marks. So the final part of the question says the following program uses a condition controlled loop, and it has the code. Complete the trace table to test this program. So if you're unsure anything about trace tables, I recommend watching the video that I've done on YouTube for trace tables, and it gives you some real examples to work through, and once you've actually done it a couple of times, it's actually quite easy to do. So have a little look at the program, think about what you would be writing into the table at the bottom. Even if you have an attempt and you get some of the table correct, you're still going to pick up marks. So I advise you to just have a little go. Use common sense, read what's actually in the program, and just do your best. Okay, pause the video, try to fill in the table, and we're going to have a look at the mark scheme. My advice would be that not always have to do all of the rows in the table. I'm not saying you don't in this particular case, but sometimes you don't necessarily need to use all of the rows. Okay, take time to study this particular mark scheme. Compare it with what you've written down in your table. At the very least, you could have put in your x and y at the beginning and got 1 mark, just for saying what the original values for x and y were. If you've actually managed to trace your way through the program and realised that the output would be 5 at the end, then you could have got a mark for putting the output as 5 as well. The others are essentially you get 1 mark for each of the different groups. So where it says MP1, MP2, MP3, you need to have all of those correct to pick up the marks. What you essentially need to be doing is checking the values of x and y as they are changing through the program. You also need to figure out how many times it's going to repeat, and that is what gets you the output at the end. Again, if you are struggling with this and can't understand how we've got this output, then go and watch the video about trace tables, and hopefully it starts to make sense. Part F. A teacher writes an algorithm to store the name of the game a student plays each night, for example, OCR Zoo Simulator. Variable.length returns the number of characters in a variable. And variable.upper returns the number of characters in variable in uppercase. Valid equals false. While valid equals false, game name equals input, enter the game name. If game name.length is greater than 0 and game name length is less than 20, then games played equals game name.upper. So this is showing us that we can use this function .upper and it will make it uppercase. Valid equals true, so it's changed valid from false to true, and then print valid game name. If game name.length is greater than 0 and game name.length is less than 20, then it will do that. So in other words, if it's less than 0 or greater than 20, then it will go to else, and that will say game name is not valid. The question says, the algorithm needs testing to make sure if the if-else statement works correctly. Identify two different pieces of test data that can be used to test different outputs of the algorithm. Give the output from the program for each piece of test data. So you need to think about what you could actually type into the game or into this program to see whether it would work or not and what you would expect the output to be. A little bit strange to ask a question about this when we've already answered the question about test data, but here we go. So have a little go and we're going to look at the mark scheme in a moment. So here's the mark scheme for that particular question. It says test data either 0 or less or 20 or more, and that would actually return an error because that is not allowed. And the other test data you could use is between 1 and 19, and that would actually be allowed. So you just need to put those two different pieces of test data in. This feels like the world's longest question, but now we're up to G. It says the teacher asks students how long they spend completing homework. Students answer in minutes and hours. For example, 2 hours 15 minutes. The teacher would like to create an algorithm that will display students' inputs in minutes only. Identify the input and output required from this algorithm. So you need to study the question carefully. If they're already asking them how long they spend and they're putting minutes and hours in, what would you need to change to get it into minutes only? What would you ask for them as an input, and what would the output be? So this part of the question says a program is created to convert hours and minutes into total number of minutes. The teacher wants to create a sub-program to perform the calculation. Program's been started but is not complete. Complete the design for the program. So it's testing whether you know how to create a function and also whether you know how to call that function as well. So in the third line where it says final total equals, that is going to be you using that function that you're going to create to actually work it out. Also, you're going to need to actually make the function that will do this particular calculation. This is a very difficult question. It's been targeted at the high grade students, but just have a little go. If you've studied functions at all, you might be able to get at least 1 or 2 marks if you just have a little go at the question. And then you're going to want to pause the video because we're going to analyse the mark scheme for the last 2 questions. So 8G part 1, one of the most ridiculous questions I have seen, is basically asking you what the input and output used to be. Incredibly easy question, but worded very confusing. So literally all you needed to say is that the input needs to be hours and minutes and the output is number of minutes, which is blatantly obvious, but the way the question was worded is confusing. So hopefully you managed to see between the lines there, and that was worth 2 marks. For 8G part 2, you have to call the function correctly using hours and minutes as your parameters or arguments. And then to actually create the function, you need to basically convert your hours first and then add your minutes. So there's 4 bullet points. You need to put in the function getting called correctly, so total mins with hours and minutes in the brackets. And when you are creating your actual function, you need to give it a sensible name and put your parameters in, and then do the actual calculation and make sure you put the word return in as the third point. Okay, check your marks and then we can move on to the last question. On to the final part of the world's longest question. We are on 8G part 3, and it says the following flowchart outputs a message depending on how long each person has spent playing computer games. And we've got another little flowchart showing us what is happening. So really you need to be kind of well studied on use of flowcharts, but also being able to translate a flowchart into code. So it says rewrite the flowchart as a program, and you can either use the OCR exam reference language or a high-level programming language that you've studied, for example Python. So it says that we start the algorithm and we enter the number of minutes played. So I advise you to go through step by step, looking at each symbol and thinking, what would that be in code? So enter number of minutes played. How do I write that into code? The next bit is a decision. So how do I do a decision or a condition basically into code? And then if that is true, so if minutes is greater than 120, then I need to do something and I need to carry out a process, and it says say, so I'm presuming that means output. And if it's not true, then I say something different, so it means output something else. So this is actually a really simple question. You just need to study the algorithm a couple of times, see what the program's actually asking of you, and you should be able to get 4 marks with a simple program. So have a little go, take your time to answer this one, and then we are up to the last and final mark scheme. Okay, so this is the end of the walkthrough. Total up your marks and see what grade you would get. This is the average mark boundaries over 3 different papers. So see what marks you've got out of 80, and then you should be able to see what grade you've got. It's obviously quite clear here that you only needed half marks to get a grade 5. So hopefully you've done pretty well, and hopefully you find this video helpful.